Okay, for those of you that are just getting on here, we're going to end up working with the Pear Deck a little bit just to review for your test that you guys have tomorrow. We are also going to be kind of going back and forth, reviewing, looking at things, and we're going to be working at filling in some of the problems on 4.1, which is the entropy and Gibbs free energy worksheet. So have that handy. You'll want 4.2 handy, and you'll want 4.3 handy. You also might want to have your enzyme or your respiration posters nearby because you can use them for a quick reference, and you're going to probably study them quite a bit for your test. All right, so going back to this presentation, go ahead and jump into joinpd.com and then put in that access code. And let's start off with those ideas of lecture 1 about entropy, which is disorder, changes in free energy, what those graphs look like if they have a positive delta G, a negative delta G, whether reactions are going to be spontaneous, endergonic, exergonic. So a lot I can ask about these reactions, okay? So here we go to start off. If I give you an example of a reaction, you have to be able to diagram the change in energy between the reactants and the products. So this is a draw screen. You should be able to draw that graph. And honestly, let's just think about it. I wouldn't try to look up any answers. I would just start with this. First decision, are we building a molecule or breaking down? And based off of that decision, if you think that we're building something, that would take energy. We have to add energy. If we are breaking down a molecule, that would release energy. So energy levels would go down. Just going to give you about 20 seconds. You think you're going to start high and come down low, or start low and go up high for this reaction? All right, I'm going to go ahead and lock those screens and just get an idea of how we did here. Hopefully, we start with low energy. We're going to add energy, so we should end with high energy. All right, we are 4 for 4, so that's making me feel pretty good about that. So, which is exactly right. If we have to build something, we're going to add energy. So we start with low energy. If we add energy, then we end up with products that have more energy stored than the reactants. Good job. So with your fingers, let me ask you this. Would this reaction have a positive, so either a positive or a negative delta G? Awesome. I have to add energy to build something. Add means positive. Looking good. So since I had to add energy, this reaction is non-spontaneous. I'm going to get energy from a different source to make this reaction take place. So it takes energy to build proteins. All right, some other quick, easy points I don't want you to miss. So this is really just, I'm just going to have you do it and someone shout out the answer. If I said calculate activation energy for this reaction, what do you think?
$60.
Okay, so the activation energy is to get up the hill. Once you get to the hill, things are going to go. Okay, so it'd be 60 on this case. I can also ask you to calculate the change in free energy. Calculate the delta G. What do you think?
20.
Okay, and the change is 20. Is it positive or negative?
Negative.
Right, because like if your bank account goes from 40 to 20, it was a minus 20 over the month, right? So let me help you remember, like, because I want to make sure you don't miss it because you don't know whether you're going to have a positive or a negative here. Do you guys remember how to calculate percent change in mass? It's not on the formula sheet, but it's one you have to memorize. How do you calculate percent change in mass? I'll start to give you a hint.
Final minus initial divided by initial.
Right, phi over I, right? So that's kind of an easy saying. It rhymes, phi over I, okay? And then you times it by 100, all right? So if you remember phi, use phi here. Do the final value minus the initial value. So if you did 20 minus 40, because 40 was the initial, then that would give you your negative 20 kilojoules, okay? All right, So speaking of, if you look at worksheet 4.1, that's the entropy one. I just want to point out that this is fair game for a calculation I can ask you to do, because when we're looking at this data and what this unit is all about, it's that we have to use molecules for energy. And if you're not eating, you're going to use your stored molecules as energy. And as you use up the fat and you use up the stored CO2, if you're not anything, your mass will go down. And that's what's happening in this case for these 3 organisms. So number 1 says calculate the percent of the starting mass that was lost. That is the exact same thing as saying calculate percent change in mass for the goldfish. So you need to know, use phi over I. So if you want to write that down, I'm not going to give you guys time to calculate it, but just write down next to number 1. Remember, phi over I times 100. You can then calculate percent change in mass. All right, so this is where we kind of left off, right? And remember, we talked about, and I had you guys watch some videos, okay? So first of all, that shrew has to eat every other hour or it's going to die, okay? Why? The shrew has a high metabolism, and it has to take in a lot of energy-containing molecules and a lot of oxygen because it produces and burns more ATP per cell than the cells of an elephant, okay? So why does it burn more calories or have a higher respiration rate or a higher metabolism than an elephant? Because you think an elephant's big, so it must be higher, right? It's all about staying warm, guys. And that's a problem for the little shrew. Staying warm is not a problem for this elephant. And it's simply because size. Small things get cold faster. Why? Because of something that we talked about before, is that if you have a smaller, remember the smaller cells have a higher surface to the volume. So this shrew has a lot of surface, but less volume. So it loses heat through the surface and it doesn't have a lot of volume to make more. So it's really hard for this shrew to maintain its body temperature. So it's got to burn more calories just to stay warm, okay? As for the elephant, think of all those cells it has that can have reactions that generate heat. So it has plenty of volume and it has more volume compared to the surface area. So there's not as much surface area to release that heat. So it's a lot easier for it to regulate its body temperature, okay? Which kind of brings me to worksheet 4.3. So if you'll grab 4.3 and let's head to that back page where we kind of left off questions 10, 11, and 12, okay? I'm going to leave this up here and that's going to help us answer. Actually, I'm not because I'm going to go to those and my document cam isn't working right now. So 4.3. So expect questions like this, and it seems a little counterintuitive. If I asked you which organism, the shrew or the elephant, needs more oxygen, well, you got to read the question carefully because it says more oxygen per gram of body tissue. A lot of people are like, oh, the elephant's big, it's going to need more stuff. Well, not per gram of tissue. The shrew, the smaller organism, needs to consume more oxygen. So an elephant's breathing is going to go like this. But remember that shrew was going like this. Like its heart was beating 1,300 times per minute. So that sucker is breathing like crazy to take in oxygen, to make ATP, to keep that heart beating, and also to create reactions where it can generate heat and stay warm, okay? So on number 10, if I say name an organism that consumes more oxygen per gram of body tissue than a rabbit, are you going to pick a big organism or something smaller than a rabbit? Is a bigger organism consume more oxygen or a smaller?
Small.
It's going to be the smaller. It's kind of like the opposite of what most people think. Okay. So to stay warm, smaller organisms have to consume more materials and have higher respiration rates to produce heat and ATP to stay warm. Okay. Bird versus a bear. Which organism must consume the most oxygen per hour? You should be able to answer that question. It's going to be the small things. Which organism has a higher metabolism rate? Have you guys ever, hummingbirds is kind of a familiar organism around here. Have you guys heard about like the hummingbirds and like how many times it can beat its wing like per minute? It's crazy. Like it beats its wings and you can't even see the wings. It's moving so fast. Think of the amount of energy a hummingbird has to generate to survive. If a hummingbird goes, and I'd have to look up the statistic, but it's kind of like the shrew. If a hummingbird goes like even just a couple hours without food, it's going to die. So that's important that if you guys put out hummingbird feeders, you can't quit that. You will draw them into the area. They expect food there. And if food's not there anymore, then you can kill the hummingbirds that were coming to your house. Okay, while that feeder was full, right? They have a really high metabolic rate. They need a lot of food all the time, okay? So 12, you need to remember small things have a higher surface to volume ratio than big things. And if you have a high surface, you lose a lot of heat through your surface. So it's hard for you to stay warm, okay? Anytime, my brain doesn't quit science. And whenever it's the summertime and I'm sitting in somewhere and I'm still freezing cold and no one else around me is cold, I know why. I know why I'm shivering. I know why I'm cold. It's because I have a high surface to volume ratio. I'm not very big. I have a lot of surface. I don't have a lot of volume. So I don't generate a lot of heat, but I lose a lot of heat through my surface. So in a day's time, my husband's never cold, but me, I always find myself to be cold in situations and I'm shivering whenever he's not, okay? All right. Now, let's kind of move into, I'm going to skip a few things of this presentation just to make sure that we get through everything, okay? One thing that if you can remember this fact, if you can think of what shivering really is, that's going to help you answer these questions, like in which scenario would an organism be taking in more oxygen to make ATP? So when would they have a higher respiration rate versus when you have a lower respiration rate, okay? If you think about this, when you shiver, all that it is massive flexing of muscles, right? Well, isn't that what a workout is? Is you're flexing muscles more? You're working out, right? All shivering is a workout you can't stop. Isn't that interesting to think? As a matter of fact, it's a diet craze going on right now. So if you don't want to work out for an hour, no big deal. Go outside, get cool for about 10 minutes. And if you shiver for 10 minutes, you will burn as much energy trying to stay warm as if you did an hour's worth of moderate aerobic exercise. So people that are trying to lose weight, they're exercising, they're watching their calories. If they want to lose weight faster, dress so you are a little bit chilled throughout the day. Then you will actually burn more calories because your brain registers when you're cold. It will make you shiver, which is just making you work out. Your brain is making you work out. You don't have a choice. And when you work out, you make more reactions happen, and every reaction releases some of that energy that's being converted as heat. And then you use that heat and you warm up. Okay. All right. So we already kind of covered this, right? This little guy right here needs more oxygen, needs more glucose, has a higher metabolism, has a higher respiration rate, and has a harder time maintaining its body temperature than sweet potato over here, okay? You need to be able to explain why organisms need more oxygen in different situations, okay? All right, now, you know what? I'm going to go down to this. Maybe it's way down here. Okay. So after what I just said, shivering is a workout that you can't control. Expect questions like this. I take a warm-blooded, or you need to know they're called endotherms. If I put an endotherm in a cold environment versus a warm environment, you have to predict in which situation would that organism start breathing faster to take in more oxygen, to make more ATP, because it has to use more ATP. So go ahead and put down your answers. So which mouse has a higher rate of respiration, this cold mouse or this warm mouse? Okay, so as long as you guys remember that being cold is going to make you work out, and you know when you work out, you start breathing faster because you need to start making more ATP because you're using it more when you flex your muscles to work out or to shiver, that you have a higher respiration rate when you're cold, and your respiration drops whenever you are in a warmer environment and you don't have to generate as much heat to maintain your body temperature, okay? All right, with that being said, you got to watch out for which organism I'm giving you. This is a different type of organism. We have, again, endotherms and exotherms. Endotherms can keep an elevated temperature compared to the environment. Exotherms can't. If that cockroach is in an environment that is 5 degrees Celsius, then the cockroach itself is 5 degrees Celsius. It can't get any warmer than 5 degrees Celsius. Okay? Do you think cockroaches can shiver? Anyone ever seen a turtle shiver? How about a snake, a shivering snake? No, because they don't have the ability to generate or increase reactions to produce body heat. They can't do that. Okay? All right. Now, when you go to answer questions like this, there is a video I had you guys watch. The kamikaze lizards. What was happening to those lizards? They were freezing to death in Florida. Remember that? So I want you to think of this was the video, right? Think about the heart rate of this lizard. Okay. Now, no one did this last time, and I wish someone would have, because when we did this third or fourth block, I had a lot of people that did it. And remember I said, soak your hand in cold water. Cool off those cells, right? And then I had them trace the alphabet as fast as we could. And so some people had warm hands, and we were doing the alphabet. And when you got through the end, you put your hand up and you said, I'm done. Okay. So when I was looking at my screen, I saw 15 people with their hands up, and I saw like 5 more people still going like this. And those 5 people that were taking longer to make these reactions happen, they were the ones that cooled off their cells. So the reactions were really slow. Movement was really slow. As a matter of fact, you should have seen them try to operate their mouse with cold fingers. Like they were having a hard time even drawing things with their mouse. Okay. All right. So if cells become cold, reactions happen slower, okay? And that's exactly what's going on with our lizard here. It can't generate its own heat. So it's becoming cold. The cells are becoming cold, and all the reactions are decreasing in rate, okay? So since respiration is just a bunch of reactions, breathing is just a bunch of reactions contracting muscles, which cockroach is going to have, which cockroach is going to have slower breathing, slower reactions, slower ATP production? Hopefully. Oh. Okay, answer your question. Go ahead and answer this one for me. I only had like 4 of you answered, so. Here's another way to think about it. Do you want a cold snake chasing you or a warm snake chasing you? If you come across a snake, do you hope it's a cold one or a warm one? Because the temperature of that snake is going to determine whether that snake can strike at you or not, can come after you or not. All right. Okay. So the minority is, hold on. Oh, higher rate of respiration. Phew, good. Okay. So in this situation, that cockroach or that snake can do reactions, higher rate of reactions because its cells are warmer because it's in a warmer environment. Okay. So You guys have to just remember it's the opposite of whether we have an endotherm or an ectotherm. If you put an endotherm in a cold environment, the amount of oxygen that it takes in, its respiration rate, making ATP levels go up, okay? Because they're going to start to shiver, and that's a workout. If you put an exotherm in a cold environment, the cells get cold and all the reactions slow down. So respiration goes down in a cold environment for an ectotherm, okay? All right. Let me go back up to, okay. When I come up to this screen, okay, actually, let's do this. Let's do this one. You guys have some dots. So grab your red dot, and you're either going to put it on the words, not on the pictures. It's a little bit easier for me to grade very quickly or assess really quickly. So grab your red dot. Here I have Slim, who's an endotherm, and here I have Snake. We're going to call him Noodle. So which organism consumes less food, less calories? Which one has to eat less? Which one cannot maintain body temperature? So which one cannot shiver to keep a constant temperature? Grab your yellow dot, put it on Slim or Noodle. So which organism, and if they're at the same temperature, which organism would require less oxygen at room temperature and have a lower respiration rate? Which organism has a lower metabolic rate? Everything should be on the noodle. Oh my goodness. You guys, you make me smile. Good job. All right. I think we're pretty good at that. Let's go ahead and just make sure we understand the why behind this. So the why between the shrew and the elephant was the shrew is smaller and it's harder for it to maintain a body temperature. So it needs more reactions to generate heat. The why is different in this situation, okay? Is in this case, the shrew needs more energy because it has to complete more reactions to generate more heat to keep a temperature, a body temperature up. Whereas snake doesn't have that ability. So it doesn't need extra calories to burn to maintain body temperature. I'm gonna give you a second, just read through that because that's gonna help us write an answer here in a minute. All right. Now, I want you to, on 4.3, which we were on 4.3, worksheet 4.3, zoom on down and see if then you could answer questions 14 and 15. And by the way, ectotherm and exotherm means the exact same thing. Exo means outside heat source. Okay, now a few things I want to explain about these worksheets and these questions is, so that question that you just answered, This is a different worksheet. And this question, it's the exact same answer. So again, it's the exact same idea, is that you have endotherms and you have exotherms, and you have to be able to tell me that endotherms can regulate body temperature, ectotherms can't. So it's just kind of the same answer, but just asked a different way with the table and data, and you have to then explain something, okay? All right. The last thing, actually I have two things. So you guys know who Michael Phelps is, right? Okay, so he's a, swimmer. He's gotten a few gold medals in the Olympics, right? So his practices were about 3 hours a day, which isn't too crazy if you ask me. Like anytime we had basketball practice or whatever, it was a 2-hour practice, right? We were running the whole time. So, okay, big whoop, 3 hours a day to swim. That's not too crazy, right? Do you guys know the average number of calories a male an adult male consumes in a day?
2,500.
About 2,500. Okay. Females, we're not so lucky. I bet you I consume about 1,500 calories a day just to maintain my weight. Okay. Do you want to know how many calories Michael Phelps ate per day?
5,000.
12,000. 12,000. Okay. So here's the thing. 3 hours of swimming can't burn up 12,000 calories. But yet he wasn't getting fat. He wasn't putting on any weight. So can you tell me what the other, let's say that he was using 5,000 calories to swim those 3 hours. Okay. So where was the other 7,000 calories getting used? Because he wasn't getting fat. He wasn't storing those calories. He was using them. Can anyone tell me what his body was using them for? Right. He's in cold water for 3 hours, right? So the fact that he was in cold water for 3 hours, that was obviously lower than body temperature. He had to actually use energy just to keep his body temperature up. Something that he doesn't even consciously have to do. Your body just does it for you. So that's why he had to consume so many calories. He was exercising, but he was also in an environment where his body temperature was always being brought down and his brain was taking over. So kind of a cool fact there for you. Okay, so we're going to study for our test that we have next class. That's what we're doing now, right? I do have one more thing that I want you to do. I want you to see if anyone in your family can answer this question. Let me zoom here. We'll get there. I know that you guys have heard this idea that we are burning fat, right? When you exercise, you're going to burn your fat. You're going to lose weight. You burn those calories. So if you have lost weight and you burned off that fat, let's say 20 pounds of it, can anyone tell me where it went? Chloe?
I don't know if this is for sure right, but don't you like breathe it out whenever you breathe?
Yeah. Do you think anyone in your family is going to think that the fat that was in your body actually came out of your mouth? No. Now, it's not the fat exactly, the whole fat triglyceride or anything like that coming out of your mouth. When you break down organic molecules, remember they have C and H, like glucose. That's a sugar. It has C's and H's. Remember, when we break down molecules for energy, we pull off atoms a little bit at a time. So remember, this was half of glucose, right? And remember, when we break this down and when we remove a carbon atom, like these little black ones right here, those are carbon atoms, we make what molecule when we remove a carbon atom from the fat? What molecule do we make?
CO2.
And the CO2 is what leaves you. C, carbon, it has mass. So if something that was in you then leaves you, your mass is going to decrease, okay? So that might be something you can discuss at the dinner table tonight. See if anyone in your family has this idea down that really how you lose mass, and actually we all right now just lost mass. So some of the carbon atoms that were in us are now leaving because we broke down those molecules with those carbon atoms, and those carbon atoms are going now out as CO2, okay? So what do questions like this look like? Let's start with 4.1 because we were just on 4.1, so you probably have that one handy. Okay. So if you look at, go ahead and study questions 2 and 3. They kind of go together. As a matter of fact, this was an essay question from a test that was given to students like about 4 years ago. This was a released item. So they were given this information and they had to then come up with 2 short answer statements. Okay, so take a second just to kind of read through the prompt and 2 and 3 on 4.1, the entropy worksheet. Okay, I want to start with the third question. The best test takers give me the shortest essay answers. Honestly, whenever I pull up your short answer questions on your test, if you guys have this much written, I'm usually, my first thought is, oh man, they have no idea and they're just scrambling and they're just like regurgitating information, okay? The best test takers write me like 1 or 2 sentence responses, because to answer an essay question, there's only like one thing you have to address or 2 things you have to address for me to give you a point and so on, okay? So if we look at number 3, this would be like a 3-point question. To explain the decrease in mass. So that's one thing I have to say is why the goldfish decreased in mass. And what did we just learn? Why would you right now, why are you decreasing in mass?
We're breathing.
Okay, and be very specific. Say, to explain the decrease in mass, okay? So mass is decreasing because molecules are being broken down for energy and those carbon atoms are being exhaled as CO2. It's one sentence. Let's do the second part of that. Identify the overall chemical reaction. Guys, if you were in chemistry class, if this was a question that was on an AP Chem exam and I taught you the exact same stuff, like you guys would get this. But the fact that it was on a biology exam, my students, quite a few of you missed it, and I wanted to like pull my hair out. It said, identify the chemical reaction. In chemistry, if I say write the chemical reaction, aren't you going to be saying like this molecule plus this molecule plus this molecule, arrow makes products? That's what they wanted you to do on this biology test. And I told you in this unit, there are 2 processes. You need to flat out have those reactions memorized because it's like questions like this. Okay? So we explain the decrease in mass, identify the overall chemical reaction. So what process is causing us to make CO2 and release it? It's respiration, right? But to get this point right here, you have to write the equation for respiration. So the chemical reaction is, and remember, it all balances out with 6s. Okay? So 6 oxygens, and then you have glucose, which is C6H12O6, leads to 6 CO2s plus 6 waters. Now, if you want to go ahead and say, and ATP is made, that's fine. But it's made indirectly by using other methods, like flow of protons and substrate level phosphorylation. Okay, and then this was the second thing that broke my heart whenever I saw answers, because students didn't know what to put. In science, we give things lots of different names, and the more you're exposed to the terminology, the more likely you would have gotten this question right. So let me show you how this question could have been really easy for students. If I say connect it to a step in respiration that is responsible for the decrease in mass. If I say step in respiration, like what are some things that you would list if I said, give me a step of respiration?
Glycolysis.
Sure. Any of those 4 things on your poster, right? Do you know those can also be called metabolic pathways? So the answer for this last part is you have to figure out whether glycolysis produces CO2, whether Krebs or the PrEP reaction does. Does the Krebs cycle produce those CO2 molecules that will leave you and cause your mass to decrease as you're making ATP? Does oxidative phosphorylation? Okay. So then it says, and connected to the metabolic pathway underlying the decrease in mass. So you have to say to get this third point in the PrEP reaction, because that's where we can get some CO2. If you look at your poster there, you see some CO2 there. You can also say in the Krebs cycle, carbon atoms are removed during the breakdown of glucose, which then produces the CO2 that can be released. Okay, so there was a lot to that question, and I know students knew it. They just didn't know that's what the question was asking them to do. Okay, so really break down a question. I need to explain the difference. I need to identify a chemical reaction, and I need to connect it, and it's a metabolic pathway. I got to identify that metabolic pathway and spell it all out. All right, so speaking of breathing out CO2, here's another question, different question, exact same answer. Go to worksheet 4.2. Worksheet 4.2. Find question number 4. Question number 4, it's about a mouse and a respirometer. You don't even have to read the prompt. You can just go right down to the question or the statement right above the lines, and you should be able to pretty quickly, because it's the exact same thing that we've been talking about. Okay, we're doing great on time. So here's what I'm going to do. I'm going to touch on just a few things. I'm going to put you guys in breakout rooms, and I want you to kind of start combing through these worksheets. Like, does everyone in your group know how to answer like on this page of this worksheet? All right, let's go to this one. Like, what, do we need to review and try to fill in before we take our test next class? Okay. So one thing that I think is a pretty difficult question, if you guys go back to 4.1, if you go back to 4.1 and you look at, and I have it right here, if you look at question number 12, boy, question number 12, there's a lot of symbols and things we haven't probably heard of, like glucose 6-phosphate, okay? This whole question boils down to this. Which type of reaction, or is a reaction going to be spontaneous if it has a positive or a negative delta G? Which reactions will happen on their own? Is it ones with positive or negative delta G? Okay, the negative. All right, so let's look at what we have here. By the way, what do you call it? What do we call, or what's the term for reactions where they're put together and one provides the energy that the other one needs?
Coupled.
Make sure you remember that, okay? So this number 12 is all about coupled reactions. It's saying that to start the breakdown of glucose, remember that took ATP? The very first step in glycolysis, we put -2 ATP because glucose starting to get broken down into the next intermediate, which is glucose 6-phosphate, that doesn't happen on its own, okay? Because that reaction decreases entropy, decreases disorder, and you always need energy to decrease disorder, okay? And if you look right here, it tells you, see that positive delta G for that reaction. That reaction is not going to happen on its own. It needs energy. You have to add that much energy to get this to happen. Where's that energy going to come from? Here comes ATP to save the day. We also can use heat to provide some energy to make a reaction's delta G go to negative. But ATP can provide energy, and we can see ATP releases 7.3 kilocalories. Add those two together, +4 and -7.3. So when we actually combine those two reactions together, look at that delta G. It's overall negative. So both of these reactions, if they happen together, this will spontaneously happen in your cells. Okay? It's kind of a tricky one, so I wanted to go over that. Okay. Real quick, this is just in your notes, and I haven't really had any time to give you guys any extra instruction on these, just what you guys got in the lectures. That's why the lectures are so important, because I don't have the time to cover everything again. I just picked probably the most difficult things to understand and choose to talk about them and try to re-explain them in our time that we have in our live meets, okay? But they are important, even if I haven't talked about them in a meet. So we've talked about surface area. Folding increases surface area. So if we have more surface area because of the folding of the inner membrane, we have more ETCs, we have more ATP synthesis. So a mitochondria with folded inner membranes can produce more ATP than one that can't, okay? Again, I'm just kind of going through my notes here, so you're welcome to just look at my screen. You do have these in your notes. This was a review talking about if CO2 goes into the blood, and CO2 is made in respiration, the blood becomes acidic. You guys do need to do a little bit of review what it means. An acid makes H+ concentration go up, okay? So when the blood becomes more acidic, it affects the hemoglobin. It causes it to change its shape. Then that causes those red blood cells. They don't have brains, but they're affected by pH. Proteins change shape, and then they can release the oxygen. So you will see maybe 1 or 2 questions on that, okay? What you're looking at here is a bacteria, but honestly, it looks just like a mitochondria, except this inner membrane isn't folded. Bacteria don't have mitochondria, but they can still generate ATP, and how they do it is just with the entire cell, basically. So they have walls and a second membrane that can trap H+. So then those H+ can flow down the electrochemical gradient, and that's called chemiosmosis. So H+ flowing, that's chemiosmosis, and that's coupled with ADP being turned into ATP, okay? All right, so even bacteria, just kind of note, they make it the exact same way mitochondria does. It's just that the whole cell looks like a mitochondria. Okay, so I know you guys, if you've had any exposure to anything, you have heard before that, yes, we use sugars for energy, but what else can you guys eat and technically provide energy for your bodies besides carbs? What else is in food that you can use for energy?
Protein.
Thank you. So on my screen here, if you can see it, I'm just going to focus on this one, just this one with the purple squares real quick. I hope that you can look at this and be like, glucose to pyruvate. Oh, okay, that's glycolysis. Pyruvate to acetylcoenzyme A. Okay, that's a prep reaction. This must be the Krebs cycle. Okay. And this is just showing you that you don't have to start with glucose. So guys, if you go on a low carb diet, you don't eat glucose. Well, you're still going to make ATP, but you're going to make it from the fats in your diet and the proteins, because you break down those proteins and amino acids, and then they can be used to generate in the Krebs cycle NADHs and FADH2s. Okay. So just note that you can use multiple molecules. Do you think, now I'm missing one organic molecule. Remember, there's 4 types of organic molecules. There's carbs, there's lipids, there's proteins. What's the 4th one?
Nucleic acids.
Do you think you would ever use nucleic acids as an energy source? No, you can't, because then your cells would actually break down the DNA, and that would be detrimental to cells. So you cannot use nucleic acids as energy sources. All right, 15 minutes. We are going to, I think we're going to go into our breakout rooms, and I'm going to let you guys think more than I've been thinking for the past 15 minutes. So let me go ahead and open up some breakout rooms here. I don't care which one you guys go to. When you're there, pick what you want to do. Do you want to march through the worksheets and answer questions that we haven't answered yet? I promise you we have answered questions like them, though, on other questions. I put a practice in Canvas. Please use that, because when you guys are done, it shows you the correct answers with explanations that I type out for you. There's grid-ins, there's multiple choice, there's short answer questions. See if you can apply this information. It's difficult as it is, but then you have to apply it, okay? So if you guys want to open up a Canvas practice and share a screen and try to answer questions together, you're more than welcome to do that. You want to open up the learning targets, because someone told me in when you guys were taking the last test, did any of you have on the cell test, you had a standard error question? You guys remember the standard error question? So I had a student on the chat feature in GoGuardian say, Ms. Spencer, did you really, I'm trying to figure out what he said. He goes, you did us dirty with a standard error question. I was like, it's listed on the Unit 3 learning target that I was going to put that on the test. There's no surprises on tests, guys, if you use those learning targets, because there was a learning target that said, make sure that you can calculate standard error, because that was on that Unit 3 learning target sheet, okay? So I didn't do you dirty. You were shown, or you were told, you just didn't use your learning targets, okay? So feel free to go through those as well. All right, let me get those links on here. And you guys use each other for the next 13 minutes to try to help each other out to get you more ready for your test. Again, I don't care which group you go into, get there and study a little bit together.